This video covers Hooke's law. Now, how is the length of a bungee cord and the height of a platform calculated so that the jumper just misses the surface of the water below? Well, we can use what's called Hooke's law. Now, if you added weights to a spring, you would discover that the force T, or the tension exerted by the spring, is proportional to its extension x. Okay, and that's known as Hooke's law. So Hooke's law, tension equals, or T, the force equals K times X, where K is the spring constant, and that K varies from spring to spring. So different types of springs will have different spring constants. So if we look at an example, calculate spring constant of a spring of force. If a force of 20 newtons produces an extension of 5 centimeters. So the first thing, we wrote down our information. Our force, or our tension, is 20 newtons, and our X value is 5 centimeters, but we need that in meters, so 0.05 meters. Now T equals K times X, so 20 equals 0.05 K, so our K is going to be 20 divided by 0.05, which is 400. Now if you want to know your units, our 20 was in newtons, our X was in meters, so it's newtons per meter. Now a spring is made by joining together two identical springs. A force of 15 newtons on the joined springs produces an extension of 30 centimeters. Calculate the spring constant of the joined spring. So our force, or tension, is 15 newtons, and our extension X is 30 centimeters, which would be 0.3 meters. Our T equals Kx, so 15 equals 0.3 K. So our K is going to be our 15 newtons over 0.3 meters, which would be 50 newtons per meter. So that's our spring constant. Now the next one, the spring constant of the original springs before they were joined. Now what's important here is we have two identical springs. So that means that 15 Newton tension has to exist prior to joining. Okay, because tension is constant at all points along the joined spring, but each spring is only going to provide half the extension. So whereas the extension of the two together was 30 centimeters, the extension of each spring would only be 15 centimeters. So our tension is 15 newtons, but our X is 15 centimeters, which is 0.15 meters. So our T is equal to Kx. 15 equals 0.15 K, so K is 15 divided by 0.15, which would be 100 newtons per meter. Okay, now the modulus of elasticity is the force required to extend a spring a distance equal to its natural length. So what we do with that is T is equal to Kx. So our modulus of elasticity, our lambda, has to equal K times L, which is the length of our spring. So K would equal our lambda over L. So that means T would be lambda X over L, just substituting for K. Okay, so as lambda, or our modulus of elasticity, is a force, it's measured in newtons. Now, unlike K, lambda, or our modulus of elasticity, is not a function of the length of the spring. Okay, so for example, 2 that we just did, for the joined springs, our modulus of elasticity would be KL, which would be 50L. For the individual springs, our modulus of elasticity would be KL over 2, which is 100L over 2, which is 50L. Okay, so the modulus of elasticity is the same for the individual springs as it is for the joined spring. So what you need to do now is complete exercise 9.8, page 382 of QMaths.